Today in Algebra 1 our focus is going to be on log functions. A lot of times we talk about things as being opposites. We talk about adding as being the opposite of subtracting, multiplying being the opposite of dividing. Today we're going to talk about opposites, and we're going to talk about logs and exponential functions. Now, both logs and exponentials are functions, but we're going to talk about how to be able to go back and forth from log form to exponential, and from exponential back to log. That's going to be the big focus of today. So first of all, when we start this problem, logs are really a shortened version of the word logarithms. Logarithms have to do with the fact that we actually use exponents in exponential stuff and use the inverses or the opposites. Now we kind of have a big piece right here that looks like this. You'll notice that they all have b's, y's, and x's in them, just in different positions. This is the exponential form, and this is a log form. And remember how we're going to talk about we're going to go back and forth. Now, if they by chance don't write a value here for your b, which stands for your base, you do have to assume that the base is 10. 10 is what we do our bases normally. When we count, we go by 10s, 20s, 30s. Everything's in groupings of 10, so this basis of 10 is a big deal. Now I want you to also take a look at this piece. Notice on here that I have actually added a little post-it note that has both the exponential stuff in there and the log form in there, because we're going to go back and forth. And I'm going to pull this out several times as we go to solve the problems that we have today. So first of all, we start out with this form right here, and they want us to be able to go through and solve our exponential version and be able to make it into log. So first of all, if I look at this, this is the exponential version. I'm going to write it right underneath. So when I write that, oops, that's supposed to be a 2 right there, my bad. So if I look at this, y is worth 25, b is worth 5, and x is worth 2. Now, when I'm looking at this problem, if I find out what y, b, and x are, I want to change it and put it into log form. So I have log base b of y equals x. B I know is 5, so this is going to be log base 5. Y is 25. And x is 2. So this right here is log form. That's going to be the big focus of where we're going. Okay, now I'm actually going to take this and move it down just a little so I can move this up. There we go. Now, in this problem, I want to evaluate. So to evaluate, that means I want to really figure out what this equals. Now you'll notice I added an x there. This is log form. So if I was to compare it to this, log base b of y equals x, you'll notice that there's some pairing that kind of happens. I know that b is 10, y is 100, and x equals x. Now see, first of all, using x right there just meant that I didn't have to incorporate another variable. But when you get something like this, this gives you the idea that this is what you're trying to solve for. So in this problem, I'm going to have to go back to exponential in order to be able to solve. So y is 100, b is 10, and x is x. So they want to know at what exponent can I put in here for x, so that when it has a base of 10, it's going to give me 100. Now this is kind of an easier one. Oops. This is kind of an easier one because it's probably pretty easy to see that if I put a 2 in there, 10 to the second power would give me 100. So that means x equals 2. Now in any of these evaluate problems that you're going to see, you're going to want to be able to put that equals x in the end because it's not going to be there. So you're going to want to have that value actually put in. Okay, let's take a look at the next one. Now we have two problems here. Now these two problems that are here are both evaluate. So let me flip my camera on here for a minute. Notice I still have that post-it note up here that we can kind of deal with. But if I'm going to focus first of all on this problem, I'm going to have to add that equals x on the end. So if I add that equals x, I'm going to do my general log form underneath it, so I can go through and try to figure out what values go with what. So if I line this up, that means b is 9, y is 27, and x is x. So that means you know you're going to have to solve for this part right here. Now I also know that I'm going to have to be able to use this exponential form if I'm going to solve. So y equals b to the x is going to go here. Y is 27, b is 9, and x is x. Now this one isn't as easy as the last one, because there's nothing I can do to 9 in whole numbers. If I plug in 9 to the first power, that's going to equal 9, not 27. 9 to the second power would be 81. So I know x has got to be somewhere between 1 and 2. But in the form that it's written now, it's kind of hard to see what it could be. But if I look at 27, I know 27 I can deal with in bases of 3. That's 3 to the third. I also know that 9 can be written as a base of 3. So 9 is 3 squared, and I'm going to add that x here, because x was already in the exponential part here. On this one, if the bases are both 3, that means these exponents are going to have to equal each other, which means 3 is going to have to equal 2x. So if I divide both sides by 2, I get x equals 1.5. Now if I get this answer and I'm not really sure that's what it is, I should be able to put 9 into the 1.5, and you should make sure that it equals 27 and checks out, which it does. Remember, we said the number was going to be between 1 and 2, and I can see it's 1.5, so that's good. Okay, last one. I'm going to move this over here. I'm trying to solve this problem, and if I'm going to evaluate, I'm going to have to add an x on the end. Also, there's no base in here, so again I have to assume that the base is 10. That was their rule they told me early on. So now if I line this up like this, b is going to be 10, y is 10,000, and x is x, which tells me that this part right here is where I know I need to solve. Now I'm going to go back to my exponential form, because that's how I've been solving all of these. So 10,000 equals 10 to the x. Now what I could do is go and plug numbers in one at a time here for x, see if I can get a number that happens and gives me the 10,000. So if I do 10 to the fourth in here, that's going to give me 10,000. So x is going to be equal to 4.